Hey everyone, so today we're going to be looking at the geometric power series, and I've got an example for you, f of x equals x over 5 minus x. But before we get to that example, we're going to talk about the actual geometric power series problems. So basically whenever we're solving the geometric power series problems that they give you, the main goal is that you're going to convert the function that they give you into a form of the geometric power series sum. So the sum is equal to the first term a over 1 minus the ratio. And so the main point of this problem is that you're going to convert this function into something that looks like this sum. And the reason that we do that is because if we make this look like this, then we can find a and we can find r. And this is so important because the geometric power series is only dependent on a and it's only dependent on r as well. Because the geometric power series is a times r to the nth. So basically, if you know a and if you know r, then you know the geometric power series. And if we know the sum, the formula for the sum, then we know the geometric power series. So that's why we're trying to find the formula for the sum. So now we're going to go about solving this problem. So one thing to keep in mind whenever you're solving these, whenever you're manipulating the equations, is that you want to manipulate it so that there's a 1. There has to be a 1 no matter what, because there's 1 right here. So in this case, we're going to make this 5 into a 1 later on, but it has to be a 1 no matter what. That you cannot skip this rule at all. It has to be a 1. And the second thing to keep in mind is that it has to be subtracted from, the ratio has to be subtracted from 1. It has to be 1 minus something. So sometimes they'll give you problems where it's 1 plus something or negative 1 plus something, and you have to manipulate those equations differently in order to get 1 minus a ratio. So remember, you have to have a 1 and you have to have 1 minus a ratio. So with that in mind, let's go ahead and solve this problem. So like I said, there has to be a 1 in the denominator, and there's a 5 now, so we're going to have to divide both the top and bottom by 5. So we get x over 5 divided by 1 minus x over 5. And just a quick check to see if this matches this. We have a number in the top, yes, and we have 1 minus a number. So we have everything we need, so now we can go ahead and find a and r. So a is just going to be this number, the top, x over 5, and r is a number that is subtracted from 1. And one thing that might trip you up, which you have to be careful about, is that it's 1 minus r. So if there's a negative sign here, that means that r is actually just the positive. This is r. R is not including the negative. So make sure you keep that in mind. Don't write a negative x over 5 because r is actually just positive x over 5. And now that we know both a and r, we can write the geometric power series. Again, it's from 0 to infinity. You always do from 0 to infinity because it's a geometric power series. And then it's x over 5 times r, which is x over 5 to the nth. And it's probably a good idea to rewrite this. So basically we're multiplying exponents, so we're going to add the actual exponent. So we're multiplying x to the first power times x to the nth power. So we're going to add the exponent, so we're going to get x to the nth plus 1 power. And the same is true for the bottom. It's going to be 5 to the n plus 1 power. And there we have our geometric power series. Now the second thing you want to do is find the interval of convergence. And this is actually pretty simple for a geometric power series because whenever you're solving for the interval of convergence, whenever you're using the sum, basically the only time that you can use this sum, the only time when you can have a finite sum is when the absolute value of r is less than 1. If the absolute value of r is 1 or greater than 1, then the series is definitely going to diverge and there's no finite sum that you can find. So all you have to do is take the r that you found, plug that in, and then solve. So we're going to multiply both sides by 5, and then we're going to get rid of the absolute value by making this a negative 5 to a positive 5, and there you have your interval of convergence. And keep in mind that you do not have to check the endpoints in this case, because if r is equal to 1 or negative 1, then it's automatically going to diverge because if you think about it, if you have a 1 here, 1 to the n, then you're basically adding the same number over and over again. And so you're going to keep adding that number until you get to infinity. So it's always going to diverge if it's equal to 1. So no matter what, these are always going to be parentheses, not brackets. So you don't even have to check the endpoints. So there's your interval conversions, and there's your geometric power series.